Oh, welcome back. Sorry it's taken so long to reply to the video, but I just had this question right here. And he wants to know, what is the top skill electronics technician must know, must learn? I want to start with the basics, and from beginning to mastering. Okay, I got textbooks, electricity and electronics. This book right here, it is from, let's see, 1964. Okay, 1964. This book here talks about electronics and electricity, tubes, circuits. You're talking about analog circuits, how motors work, all this stuff, how everything was back in the day. Before you got to digital, this is all analog, okay? This is before analog and discrete. This is before transistors. Well, I wasn't getting into transistors, but this is talks about both tubes and transistors, okay? So, knowledge. You gotta have knowledge. This here, introduction, circuit analysis. This goes over, all kinds of stuff. It just goes power circuits. You're talking analog, you're talking digital circuits, you're talking transformers, you're talking three-phase, sine waves, you name it. Capacitance, resistance, inductance, all of that. You have knowledge. You're going to have knowledge of how circuitry works, how, you can expect logically how chips work, logically how resistors are, transistors, capacitors. On my main channel, this is a second channel that I do, but on my main channel, I have had probably over 800 videos that talked about circuitry repair and common household appliances, TVs, you name it, how to fix it. And it's just a basic knowledge of how to learn how to work on things. You do everything with your hands. You also got to have a good mindset. I just got done repairing a Delfield refrigerator from a guy that's like 900 miles away from me. He lives in South Carolina. I live in the state of Illinois, here in America, United States. And I had no power cord, no nothing, just a circuit board, and the description basically saying that it kept this commercial refrigerator from working, from cooling down. So going through the circuitry, I used an ohm meter. This is your next step. You gotta know how to use an ohm meter. To be a top technician, find an ohm meter that you like. Don't get a crappy one. Get a Fluke, or one you can afford. Just go on eBay. Get a desktop Fluke, or a 6-digit ohm meter, voltmeter, whatever you want to call them. Start with the basics. Go get your Simpson analog meter. Nothing wrong with that. Learn how the circuits work. You can go through an ohm outer circuit with just this without having a bunch of high-tech equipment. Sure, it's great to have, but if you're a guy that's just starting out in the field, voltmeter, an ohm meter, something that can check diodes, maybe even capacitors, pairs. Don't even worry about ESRs at that point. You just need something to be able to hone your skill and finding the short in a circuit or an open. Just checking fuses, just checking resistance, just checking shorts. 9 out of 10 times, I've done most of my repairs with just a simple ohm meter. Ohming it out, going from trace to trace. I can't tell you how many circuit boards that I repaired that I don't have schematics for, because I'm going through and I can look at this circuit here and, okay, this is the DC voltage coming in, I can see that this is the voltage regulator here. Not even going. This is just a Arduino Uno board or whatever. There's your voltage coming in. That right there is going to be your voltage regulator. Up here by my finger, looks like a fuse. Yep. Okay. So, knowing that much, you know where to check your voltages. You know what the voltage coming in to the circuit board, and you know where to check it. There's a ground tab, the biggest tab on your voltage regulator, which will be up here. That's going to be your ground tab, 9 out of 10 times. Then you can go from the input, and then you go check for the output. You check for the input, and let's say input is 10 volts. You want to make sure you have 10 volts coming in, and you're probably going to have 5 volts coming out. And if you don't have 5 volts coming out, then you need to separate the circuit. Separation of the circuit is pretty simple. You want to make sure that the voltage regulator is actually good. So you can actually take and kind of move this one leg up. It's kind of hard to do it, but you can do it. You have to take and remove this from the circuit board and just solder just the back tab and the right leg. The center tab and the center leg are connected. And you're going to leave that other one open. So you can measure and see if it has 5 volts coming out. If it does, continue on. What you're going to do is you're going to take and find, most times, you can take and put your finger on something. If it's hot, probably going to be a problem. So, not always that this do thing, but you're going to have common sense. It's the biggest thing, working on troubleshooting stuff, electronics, no circuitry, no schematics, no BOM file, no information that's out there in the wild. You yourself are discovering something new for somebody else. That's what you got to do. You got to figure out how circuitry works. That's why I'm important of having a background of electronics and learning and knowing how logically everything works. You have input, you have output. You have a voltage supply, you have ground. You use those for your references for everything. Everything in electronics and electrically have just those simple components right there. Generally, you're going to have a fuse. Make sure your fuse is good. The biggest other thing that you're going to know how to do, other than just logically learning how to make everything work, is soldering. Soldering, it's a lost cause anymore. Soldering, it doesn't matter what kind of soldering iron you get starting out. You want to get the fanciest one, you want to get the cheapest one. I'll show you what I've used in the past. This guy right here, it is ESD safe, and DB936D plus. Got a hole in the bottom of it. I went and found this at a rummage sale. I paid $5 for it. It's isolated from circuitry, so I don't have to worry about it shorting out anything. I've also got one of these Walmart specials, or whatever special. Could be, it's a Weller brand, so it's actually not too bad. It's got a little light in the front. It's a non-isolated circuit. So I'm out there soldering wires for a car or whatever. I've used this in a pinch. If I'm going out somewhere and they left this somewhere here, I can use this. It cost me $5 for this. I think this actually came from like Harbor Freight or something. Learn how to solder. Be proficient in soldering. Soldering is going to save you. I can't tell you how many times I've picked up circuit boards out of TVs or door controllers that I've worked on, or belt scale components, or even medical devices that I've found solder joints being the issue. It's for manufacturing. It happens everywhere. It happens medically, it happens militarily, it happens domestically. Everywhere you're going to have somebody, somewhere, some machine that's not going to find that one joint that's going to crack. And it may not be a process problem. It could be just that they have a soldering-free thing, lead-free, I mean. And lead-free over time will crack. And soldering from the 70s and 80s, they had a very corrosive flux, will also cause issues to your traces. You got to know how history works. That's going to be one thing that I'm going to come back on to not only do you need some old books to learn from, you need somebody that's old to learn from. Somebody that's been in the field and seasoned. You need a mentor. That's going to be one of your top skills. You can learn all you want from yourself, but you can't always know everything. And that's fine. Just keep learning daily. Figure out something new, how stuff works. But having somebody that's already been there that can show you the rope and kind of put you in a way that you can take and troubleshoot circuitry will expedite your time in learning how working on electronics works. That's going to be one of your biggest things. Finding somebody that's knowledgeable and skilled. Be humble. Don't be, I have a bachelor's degree and blah, blah, blah. They don't care. They got 20 years under their belt. They already know how to do everything that your bachelor's degree and blah, blah, blah means. It means nothing to them. If you don't know how to do this, your piece of paper that sticks on the wall, nobody cares about. You got to know how to do the basic stuff before you get into big stuff. So I hate preaching to people online because I know this guy he makes videos and I've seen his videos and he's a very knowledgeable individual and that's fine. He asked me a question and I'm responding. So I'm not trying to be derogatory or anything. So you need to know how to logically get into your electronics, get a voltmeter you love, fall in love with it. I actually had one in high school that I used. I took electronics in high school. And the same voltmeter that they had, it was a fluke, and I had it in high school that I used, is the same one that I used in college. So I had it in 4 years. I learned how to use this voltmeter. I knew what the resistance and what the diodes were, what I expected to see from different things for voltage drops and whatnot. And I got my first job. It had the same voltmeter. So for 10 and a half more years, I learned with this voltmeter. So I had the same voltmeter for almost 15 years. And I learned from it. It was a fluke. And, I'm not knocking on any other brand. You just learn what model, brand learn it, use it, troubleshoot with it. That is going to be your biggest tool to learn how to do stuff like that. So it's a top skill. Electronic technicians, I don't think you need to know how to write blueprints and draw schematics and all that. Maybe learn how to do reverse engineering. That's part of knowing how circuitry works. You have your input, you have input, you have input, and that input goes to somewhere else. You can take this voltmeter and go from boom to boom to boom to boom and figure out where the next voltage is going to. You can also look this chip up and go, okay, that's where the voltage is. That's where it's supposed to be. VCC, VDD, that's where it's supposed to be. You know that much. That's how it works. So if you can figure out the circuit layout and how everything works that way, use that same knowledge and skills and going on to the next control board. That's all I can tell you, is you're going to have to learn and you'll fail. I've failed. There's boards out there that I've never figured out, and it's okay. Failure's part of the process. If you don't fail, you're not learning. And that's part people don't understand. You want to succeed, everything that you do, it happens. Not everybody's going to be able to figure out everything. There's so much involved with circuitry like this. You can take every part of that and blow it off, and you should still have a short. Internally, there could be a short inside some layers of boards. That's what happens. I've found that out. I've gone through and I've repaired stuff and taken literally everything off the board, and it still had a short. And that's when I realized internally it had a short. And at that point, I had to scrap it. Nothing more you can do. Say processors short out and you don't have a file to put back onto it, firmware, what can you do? If you're not the OEM vendor, or if you don't have that file readily online, not much. Stuff you can do, stuff you can do. Biggest thing else you need to know is looking up parts and finding out their schematics and how the chips work and circuitry works. You can look up circuit components and figure in all that out. That's good. Go on Google. Google the part number, figure out what the part number is, figure out what the layout is, how it works, study that circuitry, and you'll be able to figure out how that works for this. It could be something like, say, this chip here. You look it up and it's going to tell you what kind of voltage regulator essentially they would use as an example. And if there's a voltage regulator on there that has the same bias voltage like this does, sometimes if that component is completely burned out, you can take and figure out what that next component is supposed to be. So, yeah. Next time I want to talk about the oscilloscope. Now, this is just a 40 megahertz. The B&K Precision oscilloscope. I paid $20 for it. You know, and I paid $10 for a probe. It does what I need to do. You can see the square wave as an example of what it's supposed to be doing. And you can adjust this. You know, triggering, making it faster and whatnot. Sure, it may not be a digital oscilloscope, but for what I'm going to be using it for analog circuitry, who cares? You know, as long as you can make it work for you, and you learn how to use an oscilloscope, you can use that oscilloscope the same way I was telling you how you can do that with a voltmeter, except now you have an oscilloscope and can go from pin to pin and see what input and output is. Especially with analog circuits. Mostly with analog circuits. They're like 555 timers, 556 timers, or 556 chips. A lot of times, and then in a door controller world, let's say a product named Besom, they would have these timer chips. You have an input and you have an output, 2 and 4, maybe even 6, and expect to have a square wave on 4 and a higher low on pin 2, just an example. And you can actually use the oscilloscope, connect it to ground, and see the output. And if the output is not 5 or 0, and the output is 2.5, you know for a fact there is something wrong and just an ungeneralized circuit to and from. It could be the chip. You can take and pull the chip out, lift the pin, check it again, and see with the scope that if you have a high or a low, or if it's mid-range. If it's still mid-range, you have a bad chip. You know, logically, the oscilloscope is your best friend. Next to this. And even more so to the soldering iron. You know, you're going to have all this stuff. And so that's what I think about the top knowledge of working on electronics, is you have the basics of information that I just showed you here. Go work for a company that works on variety equipment, and that's how you're going to learn the best, is working on variety equipment. And you can use your basic knowledge and accumulate over the years and just going from place to place and working on equipment here and there and just have your skill, you know, your biggest skill is learning how to solder. 100%. Biggest top skill is going to be learning how to solder. If you can solder, you can save the day. Next to troubleshooting, you can use a voltmeter or a oscilloscope, mostly a voltmeter. You can measure out stuff. A little bit of knowledge in your head, looking at parts. A little bit of other tools you can use. That's all you really need. And those skills right there is going to hone you into everything you need further on in life. Now you want to branch off and go into embedded systems. That's another class, another story down the road. You know, I'm going through that myself. I'm learning how to do embedded systems in the future. So I've already done firmware flashing. I've done firmware testing. I've done production firmware testing and loading equipment. Even doing it for non-OEM pieces of equipment, finding their firmware from good chips and putting it on brand new chips and making test jigs. that stuff you learn over the years it'll accumulate and it'll help you out. That's my best advice is learn your basics, get your hand dirty, and enjoy it. Because it's going to take you for a wild ride. It's going to be frustrating. It's going to be really exciting. It's going to be sad moments. It's going to be happy moments. That's the way electronics is. It's a puzzle. It's a very mindless puzzle. I shouldn't say mindless puzzle. You have to use your mind for a lot of things, right? But it's a visionless puzzle. If you look at a puzzle like a crossword puzzle or a map, and you're stuck in a map. Here in America, we have cornfields, and you can walk out in the cornfield, and you try to find your way through this maze. It's the same way with this circuit board. It's a map. You're trying to get to one destination to the next. That's what the voltage is. That's what the data is. That's all it is. This is just a circuit board. It's a road map of information. And it's your duty, if you want to get into electronics, to figure out where the stops are, where the brakes are, where the road accidents are, fix the pothole, and make it better. Hope you learned something. Thanks for watching. Please subscribe, and we'll see you next time.